What's up guys, and welcome to this new video about building a professional authentication module. In this video we are going to use MVVM Clean Architecture, reusable composables, unit tests, professional programming techniques when it comes to view model and state management. Also we will have a look at the performance or how we can increase the performance so that we avoid unnecessary recompositions. And yeah, I think it's cool to have such an authentication module which you can then take and apply to your own projects, because there are a lot of apps out there which require login and register functionality. Let me quickly show you how this will look like. For the login view, we have an email address field and a password field. If I enter something here, then you can see we have a live form validation. If I also enter a password, then you can see we have no valid email as the hint for the form validation. And if I enter an email address, then the hint is gone and we could log in. But let's navigate to the register screen first. In case we don't have an account yet, then we have this screen with an email address input and two password fields for the password and for the password repeated. Here we can enter an email as well. And for the passwords, we do checks in the background if they match to each other, if they contain a special character, at least one, or an uppercase or a number. Let me also show you this. If I enter the same password 2 times without any number, then we have a hint. Password needs to contain at least one number. Then we can have a look at our passwords. We can also hide them again. But for the first entry, we can then check what's missing. And here we entered a number now, and then we get another hint. Password needs to contain at least one special character. Then we can enter this special character. Now you can see the passwords do not match. And if I also enter the special character on the password field above, then the hint is gone and we can click on register. Now we have a little simulated loading for the backend check, because we don't do a backend network request, because I assume that you have your own backend solution in case you need login and register functionality. This is more about the general authentication module, which you can then take and modify for your own needs, or also don't modify it and just take and expand it with the network calls, for example. Alright, okay, I'm here in an empty Jetpack Compose project, and the first thing I would like to do is go over our dependencies we need for this project. And by the way, you can find them in my GitHub's repository, which is linked down below, so you don't need to type these dependencies off. Here we have the dependency for Dagger Hilt in our build.gradle for the project, and also the Dagger Hilt plugin here. And then in the build.gradle for the module, we will have this dependencies down here in this dependency section. We need an icon which comes from this material icons extended. Then we have the dependency for compose navigation and also the Dagger Hilt dependencies for the module. And up here we also have 2 additional plugins. On the one hand, Kotlin Capped, and on the other hand, the Dagger Hilt plugin. And what I meant by you can find them in my GitHub repository, just clone the initial project and you will have the same state than I have now. Okay, I would like to start defining the different composable components, like the bubbles with the animation, the header, the custom text fields, the authentication button. And then we can use them later and just build our UI by putting them together like we want. And for that, we will go to our root package and we will create a new package called presentation. And inside this presentation package, we can then create another package called components. When we apply the clean architecture principles, we normally have different features / modules. And inside these features / modules, we have a presentation layer for UI related stuff, the domain layer for business logic, and the data layer for data related stuff like network requests or database requests or something like this. And here in this project, in this application, we are in the Auth module. We are already in a module, and this is why the presentation, domain, and data layer are right below the root module here. If your application gets bigger, then this Auth module, which is now our root package, will be one package below the root package if in case your application is bigger. Let's also create the domain and the data package, even though we don't need it yet, but we can then see how this would look like later. And inside this components package, I would then like to start with our authentication button. By the way, we could also take this UI auto-generated package with the theme, the colors, shape, and so on, and put them in the presentation package, but I think it's fine to leave them where they are. And also what I need to mention is that I added some colors here. We don't need all the colors, but this is my default color palette, which I always add to my projects. And well, they are also included in the initial project, so you don't need to type them off. In the components package, we will create then our first composable, which will be an Auth button. And this will be a Kotlin file, a composable, and since this button only differs by the text for the login and for the register screen, we will make this a reusable composable, of course. This button will have a text of type string, a background color of type color, the compose color, the content color of type color, if it's enabled, of type Boolean, which is true by default. And then we also have a lambda function on button click, and this won't take anything and also does not return anything. Then we have also is loading, because when we are currently loading, then we want to show a circular progress indicator instead of the button text. And then we have also a modifier, which we set to the default modifier, so we can modify this Auth button from the outside. Then we will define our button. For the modifier, we will pass the passed modifier. And let's import this button. Then for the onClick method, we simply call this onButtonClick. And then we have also a shape for this button, which will be a rounded corner shape of 25 dp. For the colors, we will say button defaults.button colors. We will pass our background color. The content color is equal to content color, and also this disabled background color will be set to background color, because the button will be disabled if the form validation says we have an invalid input. Then we will disable this button, but I think it's okay to keep the original background color and just disable the clicks. And we will also have the disabled content color set to content color. Then we have enabled is equal to the passed Boolean enabled, like this. And then we can open this button scope, or better said, it's a row scope. And then we will say if is loading. When we are currently loading, waiting for the result from the backend, then we will show a circular progress indicator. The color will be set to white, and the modifier will be set to modifier.size 20 dp. Or don't set it to white, let's set it to our content color, because this already works for our text content, then it should also work for the circular progress indicator. In the else case, we want to show the button text. We will say text, and the text is equal to our passed text from above. Let's import this text composable, and the style will be set to material theme.typography.body1. We can also have a look at how this button will look like with a preview. I think this is really useful, because then you don't need to start building the actual screens where you invoke then the app and have a look at it there. So we will say add preview, show background to true, and then we will define our Auth button preview like this. And here we invoke our Auth button. For the text, we simply say login. For the background color, we say orange. And for the content color, we will set white. Button click can be left empty. Is loading is set to false. And then we can go to split above, click build and refresh. And then we should see our authentication button. Well, okay, this looks a little bit too small. We have the possibility to change this with the modifier. We will simply say modifier fill max width. Let's decrease this a little bit. And yeah, I think this button looks fine. We can also check how this would look like with the loading indicator if we set is loading to true. And then you can see, okay, well, we don't have animations here, but you can see this little white dot, which indicates that the loading indicator starts with its animation there. Okay, all right, then we can close this. We can also close all the previously opened files and go to our components package again, and we will create our next composable. This will be called text entry module, and this will be, of course, a file composable. text entry module, and here we will need a bunch of parameters because such a text entry module will be a text field and the description above. We will make this one composable so we can just enter them later when we are in our login or register view, but therefore we need a lot of parameters. First, the description of type string. Then we also need a hint of type string, an image vector of type image vector, then the text value of the text field of type string. Then we will also provide the possibility to pass a keyboard type. We will set this to keyboard type.ascii by default, but in case you want to pass some other keyboard type, then you have the possibility to do this. We have also a visual transformation, which we will set to visual transformation.none by default, but later for the password fields, we need a password visual transformation so that the password is hidden behind these black dots. Then we will also have a text color of type color, then a cursor color of type color. You see, I make this really general so that you can really use this and apply all the things you want later. Then we have an onValue changed lambda function, which provides us a string and returns nothing. And we have a trailing icon of type image vector, which is optional because not all our input fields have trailing icons. Only the password input fields will have a trailing icon where we can then click on to show or to make the password visible. Then we have an onTrailing icon click, which is a lambda function that does not take anything and does not return anything, and it is also optional. And the last thing is a modifier, which we will set to the default modifier to allow us to modify this text entry module from the outside. In this function block, we will first start with a column. This column takes our passed modifier from above, and let's also import this like this, and then we can open the column scope. And first we will have a text for the description. Here we will pass our description. Let's import the text composable. The color will be set to our text color, and the style will be material theme.typography.body2. So this will be our description, and I'm not sure why we have an error here. Is this the wrong color? Oh yeah, we have the wrong color imported. Let's use the compose color, then the arrow is gone. And then below this text, we will have a text field. For the modifier, we will say modifier.fillMaxWidth. We will have a little padding to the top of 3 dp. Let's also import dp. Then we have a border of 0.5 dp and our text color and a rounded corner shape of 25 dp. Then we have the height of 50 dp and a shadow of 3 dp, rounded corner shape 25 dp. The next thing is our value, so the actual text input. Here we will simply pass our text value. The colors will be text field defaults dot text field colors. For the background color, we will pass white here. For the cursor color, we will pass our cursor color, and this hard-coded white color is not that general, but I think text fields should always be kind of white. And then we have a focused indicator color, will be set to color.transparent so that we don't see anything there. And the unfocused indicator color is also set to color.transparent. Then we can pass to the onValue change parameter our onValue change passed function from above. And the shape will be set to rounded corner shape 25 dp. Then we will also set the single line to true. And the leading icon will be an icon. And for the image vector, we pass the image vector. Let's also import icon. Let's rename this to leading icon. This is a little bit better. Then image vector. Then we have content description. I will just set this to null. The tint will be our cursor color. And the next parameter will be our trailing icon. And here we need to check if the trailing icon is actually null or not. We will say if trailing icon is not equal to null, then we can say icon For the image vector, we will pass our trailing icon. The content description will be set to null again. The tint will be set to our cursor color, and here we say modifier is equal to modifier.clickable. Here we need to check if our onTrailing icon click lambda function is not equal to null. If this is the case, then we can invoke this onTrailing icon click function. The next thing will be our placeholder. Here we will pass the text, and for the text we will pass the hint. The style will be set to material theme.typography.body2, and the text align will be set to text align.start, but I don't think we actually need this. Yeah, let's just remove it. And then we will also have a text style. For that, we will pass material theme.typography.body2, and then we have the keyboard options. There we will pass our keyboard options, and the keyboard type will be set to our keyboard type. And the last parameter before we have finished this composable is our visual transformation, where we simply pass the visual transformation from above. All right, okay, this is a huge text field, and I would suggest that we have a look at the preview, but I think I will just copy and paste this because I don't want to bore you with invoking this composable inside the preview. But I think this looks really cool. Of course, this eye icon at the end as the trailing icon does not make sense for an email address field. And yeah, but I think the styling looks pretty cool. We can also enter a value here, text input like this. And then we can say for the visual transformation, we want to have a password visual transformation, and then we can have a look if this also works. And yeah, I think this looks also pretty cool. So we can continue with our next component. The next component will be our bubble animation. For the 3 bubbles at the bottom, which go from left to right and kind of animated and gives a nice feeling. Here we can, we don't have a class, we have a composable bubble animation. Here we have 2 colors, the bubble color 1, because this will be a gradient, linear gradient, where we need 2 colors. We have the button color 1, imports the compose color, and then we have the button color, the bubble color 2, which is also of type color, and also a modifier again to allow us to modify this from the outside. First, we will have a val infinite transitioner is equal to remember infinite transitioner. Then we will have a box where we pass our modifier and open this box scope. Here we will have now a little bit of boilerplate code. Maybe there's also a more general way to create this, but this bubble animation is anyway only a little bit of a play around. So we will first start with val x value by infinite transitioner.animate float. The initial value will be set to 100f, the target value to 1340f, and the animation spec will be infinite repeatable. The animation will be set to tween. The duration will be 7 seconds. We have a linear easing, and the repeat mode will be repeat mode.reverse. Then we also need to import the missing dependency, and the arrow is gone. So this is the x value for the first animatable circle, so the horizontal way. And we also need a vertical way. Here we can say val y value by infinite transitioner.animate float. For the initial value, we will say 100f. For the target value, 700f. The animation spec will be set to infinite repeatable again. The animation duration will be, or the animation will be tween with 6 seconds duration. Again, we have linear easing. And the repeat mode will be again set to repeat mode.reverse. And here we also need to insert the parameter name. And this is the animation definition for one bubble. We can just copy and paste it down below for the second and for the third bubble and change the parameters a little bit. Here we will say x value 2, y value 2. Here we will swap this 2 values so that the bubble differ from each other. Here we will say 400f, here 200f. Increase the duration to 7 seconds and here to 8 seconds, and then this second button behaves a little bit different. We can copy and paste this again for the third bubble, and again this is only a little bit of a play around. You can try to make this more responsive without hard-coded values, or also just leave it completely. This is not necessary here. I also just tried around a little bit with it. Here we will say 1000f and here 400f. Change the duration to 7.5 seconds. Here also change it to 150f. The target value will be set to 600f, and we will also decrease the duration to 6 seconds. Then we can make use of a canvas. For the modifier, we will pass modifier.fillMaxSize, so the canvas will expand to the box size. And then we can draw our circles. Here we will say draw circle. For the brush, we will say brush.linearGradient. We will pass a list of colors, the bubble color 1, bubble color 2. Then the start will be set to offset x value minus 90 and y value. And the end will be set to offset x value plus 90 and the y value. Then we will also pass a radius of 100f. The center will be set to offset, and for the x value we will pass x value, and for the y value we will pass the y value. Then we can just copy and paste this 2 more times and change the values here. The x value 2 is used for the second bubble, and also of course the y value 2. And here for the third bubble we will use the x value 3 and the y value 3. Also need to change this above here. Here we will also use the y value 3 and the x value 3. And we will make one bubble a little bit smaller than the others. And yeah, then we are good to go to try this out in the preview. Let's add a preview. Show background is equal to true. Composable bubble animation preview. In here we will invoke our bubble animation. For the bubble color 1 we will pass orange, and for the bubble color 2 we will pass gray. And then we also need to define a modifier. The modifier will fill the max width, and for the height we will say 250 dp. Then we can go to split, and there we can have a look. Render issues. Okay, let's try it again. And here you can see the preview does not show animations, but we can click on this run preview here and open the app, and then you can see the animation kind of works, and we have smooth animatable bubbles here. And yeah, feel free to adjust them to your own needs or just leave them out of your application. I think they are a really cool play around. Okay, all right. The next composable component will be our header background. So the half circle at the top of the app, we will call this header background. This will be a composable. This will be a rather short composable header background, which takes the top color of type color and which compose UI graphics color, the bottom color of the same type. Then we will also have a modifier, which will be set to the default modifier. And then we have a well color list is equal to remember. And here we will say list of top color and bottom color. And of course, we could have used this color list for our bubble animations as well. So we would have only one central list, but well, this is okay. The canvas then takes the modifier, and in here we will draw a circle. With draw circle, the radius will be set to size.width. The center will be set to offset center.x and minus size.width divided by 1.2f. Let's also import offset. And we will also have a brush, which will be a linear gradient. It takes our color list, and the end will be set to offset. We will pass center.x plus 500f and 0f for the y value. So what this does, and these parameters here do, They kind of take the circle we define here and move it really above our app's visual scope, and then we will only see part of the circle, the bottom part of the circle, and this will give us this header background. We can have a look at the preview, show background to true. Then we will have a composable background header preview. Here we will invoke our background header, header background. Well, let's swap this name. For the top color, we will pass orange. For the bottom color, we will pass white, gray, orange. This is what we also use in the login and register screen later. Then we will also have a modifier. Here we will say fill max size, and then I think we should already see the right header. Let's click on build and refresh in our preview, and yeah, then you can see we have this header background, and we should also change these names to left and right color, because first I was using a gradient from the top to the bottom and not from the left to the right. So let's change this to left color and this name to right color, then it's more understandable. Alright, okay, this was it for our composable components for the register and login screen. Now we will go to our domain layer, where we will provide the business logic for validating the login and register input, so that we can use this business logic to determine what we should actually show to the user. We will also validate later that our business logic actually works properly with unit tests. In our domain package, we can create another package called model, where our business models belong to. Here we will create an enum class called login input validation type. This enum class is kind of a language for the ViewModel because our business logic will return such a login validation input type, and then the ViewModel can determine what should be shown, how to update the state depending on this type. And as I said, this type is kind of a language which tells us that we have, for example, an empty field in our login input, because we don't want to allow the user to press on login if there's at least one empty field. Then we also want to avoid clicking login if the input of the email text field does not contain an email. Or we can also express with this enum class language that the input is actually valid. Then we can go to our domain package and create another package called use case. And in this use case package, we can put use cases which represents our business logic. The first use case will be validate login input use case. Then we can override its operator function, because we can then invoke this use case later in a more convenient way. This will take an email of type string and the password of type string, and it will return a login input validation type. In here we can then first check if email.isEmpty or password.isEmpty. If this is the case, we can return login input validation type empty field. Then we will also check if the @ sign is not in the email string, then we can return login input validation type dot no email. And I know this check is not enough to say if this is actually a valid email or not. We could also check with a regular expression, for example, if there's only one @ sign, but then the user can also type in invalid emails. Well, this should more be the principle of this use case with this enum class. You can expand this and use a regular expression for that. And for now, we will only use regular expressions later for our register input to check if we actually have an uppercase, a special character, and so on, because we can't really prevent the user from putting in something that does not make sense for an email. Yeah. And if we are here in this line, we can then return login input validation type dot valid. And now we are good to go to write 3 or 4 unit tests for this use case. And I like this about use cases because they can really be tested in isolation, and we don't need to provide fake or mock implementations or something like this. And yeah, this makes them really powerful in my opinion. Of course, you shouldn't write a use case only for sorting a list because this is kind of a one-liner. But if you have more complex business logic, then they are really, really cool in my opinion. You will see this is even more powerful when we have the valid register input use case, because there we don't have only two if checks. We need to check for special character, we need to check for uppercase, for numbers, if the passwords actually match, empty fields, and so on. And there you will see how cool these use cases are and how easy we can test them. For testing, we first need to add a dependency in our builder Gradle for the module, and we can insert it here. Below this test implementation, we will use the Google Truth library, which is a powerful testing library. And I think we can also just remove this JUnit 4.12, and then we can click on sync now. After the sync was successful, we can go to our test module, go to our Auth module here, and we will have the same package structure in our test module like we have in our production module. So we will create a domain package and use case. And in this use case package, we will then create our validate, login, input, use case, test. You can also select the more convenient way by going to the use case, click on generate, test, select JUnit 4, press OK, and then you could also press OK here, and then the test class will be generated automatically. But I think it's cool to show where the test is actually located, because it's in this test module and not in the Android test, because we will do unit tests here. And in this module, the Android test module, there's some kind of integration test where we actually need the Android operation system. And for unit tests in this module, we only need the JVM. So we can go to our validate login input use case test. First, we need a reference to our use case we want to test. Private val validate login input use case, and then we can straight initialize it here, and then we can start with the add test annotation, and then we can write our test functions. The first thing we want to test is if the email or the password is actually empty. Then we should get the login input validation type dot empty field as a return. So we can call, or we can name this test like this with this backticks. Test empty field returns validation type empty field. And then we can say val result is equal to our validation or validate login input use case. And for the email, we will pass an empty string. And for the password, we will pass something else, just password or something like this, so that one field is actually empty. Then we can say assert that the result dot, okay, first we need to import assert from the truth library, is equal to login input validation type dot empty field. And then we can click on this play sign and run the test and have a look at if it actually passes. Okay, all right, this looks good. The test actually passed. And I think we should also rename this and remove this typo. Return validation type empty field, like this. This is for the sake of grammar. And then we can copy and paste this, and maybe you also want to test if the password is empty and the email contains a value, but I think this test case is enough. Well, let's write both test cases. This goes really quick. Test empty emailed field return, and here test empty password field. And here we will pass an email with @ sign, and we will leave the password empty. And then we should also get this empty field returned. And here execute all tests, and we can see both of them passed. And now we can check on the email sign. Let's copy and paste this one more time. And here we will then say test no email, return validation type no email. And then we will just remove this @ sign, and for the password we will simply pass password, and here we also need to change the validation type, and then we can try this out and have a look. And now you can see also this test case actually passes. The last thing we want to test is if the input is actually valid, that we also get a valid response. So we can rename this to test everything is correct, turn validation type valid. Then we enter a valid email and a valid password. And here we get then the result valid. And we can check on this, run this test case. And then you can see also this one passes. And at the end, if you want to check if everything works, then you can click on this run sign and click on run. And then you can see all 4 test cases actually passed. And maybe you're asking yourself why this is even necessary, because this use case is really easy. We don't even need to test it. But well, sometimes in the future, maybe you change your check validation login input use case, and then you also want to be sure that your changes didn't affect the previous logic. And then you can just click on run again. And if all the test cases passes, then you can see, or you can be sure that your changes didn't cause any errors or so. And of course, sometimes the business logic is even more complex, which makes testing even more important. And you will see that the validate register input use case is also a more complex one, which of course requires more test cases. But after that, we can be sure that this use case actually works. Let's go to our model package and create a new enum class for register input validation type. Like we had for the login input validation type, here we had only 3 cases, but for the register input validation type, we now have more things to consider. We have the empty field case, the no email case, then the passwords do not match case, passwords uppercase missing, password number missing, password special jar missing, password too short, and the last case is valid. Now we can go to our use case package, create a new use case. This will be called validate register input use case. This will be a class, and we will again override the operator function invoke. And here we have 3 parameters: the email of type string, the password of type string, and the password repeated of type string as well. And the return type will be register input validation type. And the first thing we want to check is if email.isEmpty or password.isEmpty or password repeated.isEmpty. So nothing new. Here we again return register input validation type empty field. And also the second check is nothing new. Here we will again check for the @ sign. If @ is not in email, then we will return register input validation type no email. But now things get a little bit more interesting. We will first check if the password is not equal to password repeated. Then we will return register input validation type dot passwords do not match. The next thing we want to check is if password dot count is less than 8, then we will return register input validation type password too short. The next check, if password contains numbers like this, would be really cool to use, but we don't have this contains number functions. I would like to create an extension function of string, which can then be invoked on this password string. For that, I would go to our root package and create a new package called util. Because I think this does not belong to our business logic, such a string extension can be used everywhere. So if you have a project, a bigger project with more modules, then you maybe want to use this string extension everywhere. So we go to our util package, create a new file, string extension, and in here we will have a function string.contains numbers. This is how we do this in Kotlin. And this will return a Boolean. Then first we will define a regular expression. This can be done with the regex class. Here we will have a dot for any kind of character, and this asterisk says that we can have any amount of any kind of characters. Then we check on a number. So one number is enough. So we apply a plus sign here. And after this number, we again have the dot and the asterisk. And this regular expression now means that we can have any amount of any kind of characters. Then we need one number. And after this number, we can again have any characters. So this checks or this expresses that we have in the string at least one number. And then we will return regex.matches, and we will simply pass this, which is the current string on which we invoke this contains number function. We can also already define the other extension functions we need later. For example, the contains uppercase function, which also returns a Boolean. Here we will again have a regex, which we can define like this. First, we again have any kind of characters, and then we have A to Z, so uppercase letter and a plus sign, that means at least one. And after that, again, a dot and the asterisk for any kind of character. Then again, return regex.matches, and we will pass this. After that, we have a string.contains special char, returns again a Boolean. The regex is now regex, and first we have our dot with the asterisk, and then we have this negation, A to Z, now like this, A to Z for the uppercase and A to Z for the lowercase, and this for a number. And after that we have again the asterisk with the dot. Okay, what this means here is that these are all characters from A to Z, upper or lowercase, and also all numbers. And this negation means that it is some kind of other character which is not in this range here. And this plus says that we have at least one of them. So this expresses that we have at least one special character. Then we can say return regex.matches, and we will pass this. And now we could, of course, start using these extension functions here, but how do you want to know if this is actually working? I don't want to open the app later 10 or 20 times and try all the possibilities for the password inputs. And for that, we can again just define test cases, which then shows or validate the correct behavior. For that, we go to string extension class, click on generate, test, we select JUnit4, press on OK. And I'm not pretty sure why we don't have the automatic suggestion for the destination here. Okay, this doesn't matter. We can just go here to our test module, go to our root package there, create another package. As a quick reminder, we need the same package structure, or the same package structure is a good practice here. And in this util package, we create then string extension test, and we can start with our test cases. The first test will be functional test string contains no number, returns false when check for it, like this. And then we can say, well, result is equal to the string no number, for example. Then we check on contains number, like this. And why don't we have this? Ah, well, okay, that was dumb. These are extension functions, and we don't need a class for that. Just remove this class and put it like this. And then we can go to our test again. And this contains numbers is also misleading function name. Sorry, we will call this contains number. And then we will check assert that result is false. And for that, we need to import the truth, assert that library. Then we can click on run for this test case and check if everything works. And okay, well, we need to uncomment this. First, go to our test back and click on run again. Okay, well, let's just return register.valid. We need to return this anyway at the end. Go back to our test cases and then press on play. And then we can see the test passes, and then we can continue checking on other functionality. For that, we can copy this test case and paste it. Test string contains a number, returns true when checked for it. Here we will simply insert a 5, and we need to check this, change this to is true. And I won't press play after each test case. I will define now all test cases, and at the end we let them run all at once. The next test will be test string contains no uppercase, returns false when checked for it. So we will have a string without an uppercase. Then we will invoke contains uppercase, and this should return false. Then we can again copy and paste this, and oops, this time we have contains an uppercase, returns true when checked for it, and we can just leave it like this, change the functioner, contains uppercase, and this should result in true. And now I'm gonna paste rest of the test cases because I think that does not make that much sense if I type this off and copy and paste and all that stuff. The last test cases are test string contains no special character, returns false when checked for it. Here this string is checked, and here we have contains a special character, returns true when checked for it. Here we have the special character, and now we can go to the top and run all the test cases and check if they all pass. And now they all passed, and we can be pretty sure that everything works. Maybe you want to check some edge cases or something like this. For me, this is fine for now. And then we can close this test class, close also the string extension class, and we can continue with our validate register input use case. Okay, we first can uncomment this and import contains number like this. And if the password does not contain a number, we negate this here. We can return register input validation type dot no number or number missing like this. And then the next case, if password does not contains an uppercase, then we can return register input validation type dot missing uppercase. And let's also remove this typo, contains uppercase like this. And the last check we want to do is if the password does not contain a special character, then we want to return register input validation type dot special character missing. And now you can see this use case is kind of big, and we also want to check if this use case is actually working. So let's go to the class, click on generate, test, select JUnit4, and then we can press on OK. Now we get the automatic destination suggestion. Don't know why this didn't work earlier. We can press on OK, and then it automatically generates us this class in the right directory here in this use case package. And now we can start to define the different test cases for this validate register input use case. This time I will just copy and paste them because I think this is always kind of similar to the other test cases definition, but I will go quickly over them so that you can see what's currently going on and what's actually tested. So first of all, we need to import this validate register input use case, and I think I made a typo before. Yeah, I made a typo again, and let's kind of change this here like this. And we also have the wrong assert library here. We can import test and then import assert from truth. and import the register input validation type, and then we can quickly go over the test cases. With such more complex things to test, I like to start with a test where everything is the way it's supposed to be. Like we have a valid email, a valid password, and also a valid repeated password. And then we should get valid as the result. And from this test case, I derive then other test cases where I make small changes and test the different possibilities here. For example, here, test register input with no email gives correct return type. So I just removed the @ sign here and changed this to no email. Then here, test register input with not matching passwords. I left the email here like it was, and then I just inserted this little character so that the passwords do not match anymore. Change this here, and here test register input with uppercase missing. And yeah, here I changed the password and also made sure that the repeated password is the same, but without an uppercase. Change the input validation type. Yeah, I think you get what I mean here. Also check for number, special character, and if the password was too short, and then we can click on run and check if everything works. And again, we have, oh, this does not look that good. Okay, because I made this typo change for the use case. Well, I have to look into this. I'm not really sure what was causing this. I just rebuilt the project and then everything worked. So if you face the same error, then just rebuild the project and it should be fine. I also changed this uppercase S to a lowercase s in this use, and then we can now run our test cases and they all pass, and our use case for validating the register input seems to work fine. Alright, okay, I think this was it for the business logic. Now we can start to build our view model. Let's close this test and go to our presentation package, and also let's collapse this test module. In the presentation package, we will create another package called state. And in this state package, we will first create a data class called login state, because our view model will make use of this login state class to represent the current state, which can then be observed from our composable to show the corresponding UI elements. Let's select data class and press enter. And this login state will have multiple values. We will have an email input. This is a string, and this string is empty by default. Then we have a password input of type string, which is also empty by default. Then we will have a boolean, which indicates if the input is actually valid. This is set to false by default. Then we have a val is password shown, which is also boolean. If the user clicks on the icon, on the trailing icon on the eye, then the password can get visible or it can be hidden, and this state var is indicating this. Then we will set this also to false by default, and then the next value will be val error message input of type string, which is optional and null by default, because we don't want to start straight away with a hint for the user that the fields are empty. We will only start this when the user entered the first character. Then we have a val is loading later for the simulated network request to show the circular progress indicator. It's a boolean set to false by default, and then we have a val is successfully logged in, which is also a boolean and false by default, and we have an error message login process of type string, which is optional and null by default. And here the difference between this error message and this error message is that this one is indicating an error and a potential error which comes from the network request if some error occurs, some exception is thrown or so. And this error message is just for the hint to show the user that we have an empty field left, or that the email field has not a valid email or something like this. Yeah, this is the difference of them two. Then we can go to our presentation package, create a new package called ViewModel. In this package, we can create a new Kotlin class called login ViewModel. And for Dagger Hilt later, we need to annotate this with @Hilt ViewModel. In case you don't know what Dagger Hilt is, it's a dependency injection framework which keeps your code very clean because you don't need to take care of the dependencies. You just need to define them in a central place. And we will do this setup later, but right now we will just make use of this annotation and also the inject annotation, which we need for dependencies. And here we can say private validate login input use case, and later Dagger Hill will take care to provide us this use case. And yeah, but you will see how we can set up this later. Then we have a var login state by mutable states of login state. Let's import this and also the get and the set values for the mutable state of. Like this. We will make this a private set so that we can only modify this login state inside our view model. Then we have a bunch of functions. We will have a function on email input change. New value will be a string. And then we will say login state is equal to login state dot copy, and we will say email input is equal to our new value. This copy will reinitialize this login state and keeps all the different properties and only changes this email input. And this reinitialization causes then the UI to update. If we would only say something like this, login state dot email input is equal to new value, well, this email input is a value anyway, so we couldn't change this. But if this would be a var and we could change it, this would not trigger an update of the UI later, but we can achieve this with this copy function. Then we have the next function on password input change, which also takes a new value of type string. Here we can say login state is equal to login state dot copy, password input is equal to new value. The next function on toggle visual transformation for our password to hide it or to make it visible to the user. Login state is equal to login state dot copy. And here we say is password shown is equal to not login state dot is password shown. So we kind of toggle this. And after that, we will have a private function check input validation. And I always like to start with the state vars in the view model, then the public functions, and then the private functions. So it's always structured and gives a cool overview where different things are. We will have a validation result is equal to validate login input use case, and we already know that this use case should work because we actually tested it. Then we say login state dot email input and login state dot password input for the two parameters. And after that, we can call this check input validation from our on password input change and from our on email input change function. And now we can then process input validation type, and we will pass our validation result. So private function process input validation type login input validation type. And the reason why I put this in not protected, it's private. The reason why I create a separate function for processing this input validation type is because of the separation of concerns. This function has the responsibility to check the input validation type. Therefore, it uses the use case to get this validation type, and this function's responsibility is to process this input validation type. So both functions are really clear and only have one responsibility, and this keeps your code clean. You should always prefer small functions with single responsibilities over two complex functions. And also it's a good practice to put the functions that get invoked below the functions that invoke them. So we have this for this check input validation here. This function is defined below these two functions, and also this function here, which gets invoked here, is defined below this function here. This here would not be that good practice in terms of readability. Of course, this is not always realizable, but if possible, you should always do this. Then we say login state is equal to when type login input validation type dot empty field. Then we say login state dot copy error message input is equal to empty fields left. And we also need to say is input valid to false, because imagine if the is input valid is set to true if everything works and the user starts to delete characters, then we have, for example, again an empty field, and we should always then set the is input valid to false again, and don't forget this. After that, we have the case login input validation type no email. Here we say login state dot copy error message input is equal to no valid email, and again is input valid is set to false. And if we have the case if it's valid, then we say login state dot copy error message input is set to null, and is input valid is set to true. The last function we want to define is the function on login click. We leave this empty for now and take care of this later, but we can already invoke it then from the UI later. Okay, all right, this was it for the login view model. The next view model we want to define is our register view model. Register view model inside our view model package. Here we can again make the Hilt view model annotation, say inject constructor private val register input register input use case like this. And then we have the view model inheritance. Let me check if I also have this. Oh no, I forget it here. View model, and then we can start with our state again. For the register view model, we have another state data class. Register state will be a data class. Here we will have a val email input of type string, which is empty by default. Val password input of type string, empty by default. Val password repeated input of type string, empty by default. Val is input valid again. Well, I think it would be faster if we copied the login state and adjusted it a little bit. Never mind. Val is password shown of type boolean is equal to false. Val is password repeated shown of type boolean, which is false by default. Val arrow. Well, this can be copied now. The last four. Like this. Well, error message input is loading is successfully registered, and error message register process like this. This will be our register state. We can close this, go back to our view model. Here we can say var register state by mutable state of, and pass the default implementation of the register state. Let's import this get and setter for the delegate mutable state of, and we will make this a private set so that we can only modify it within this register view model. All right, okay, then we can go to our login view model and we can copy and paste these functions because they don't really differ from each other. We will have on email input change, and then we say register state is equal to register state.copy. Here we have the same register state is equal to register state.copy. Then we need another password function on password repeated input change. Here we will change this to password repeated input. And here we will also have on toggle visual transformation passwords and on toggle visual transformation password repeated. And we again need to change this to register state dot copy. Here again, here we will say register state dot copy is password repeated shown, and then we say register state dot is password repeated shown, and let me put this in a separate line so that it's more readable. Okay, all right. Then we also need this check input validation function. I think we can also take this from our view model, and after that we need to define our own. But now we can just copy the logic. Here we will take the register state and make it like this. And for the third parameter, we need the is password repeated input, and we also need to change this to validate register input use case. And here we can also take this function name, because we also need to process the input validation type here. Type will be register input validation type, and this will be a function, of course. Let's import this, open the function scope, and then we can start processing this type. And I decided to copy and paste this function because we have a lot of different cases here which needs to be processed. Here we have the empty field, no email, password too short, passwords do not match, password uppercase missing. And I think this would be not that practical if I type this off and only the string changes here. You could also move this logic of string determination out and keep this function a little bit more small. But well, this is up to you. This can be, of course, made cleaner, because it's only about the string which changes here. And okay, this case is a little bit different, but yeah, if you want to move the logic for determine the string out of this function, then you can, of course, do this with a separate private function. I think this is still fine so, and the function is not too long, still has its own responsibility, and it's still also readable. So for me, it's fine. And the last thing we want to do here before we continue and start with building our UI, setting up Dagger Hilt and so, is another public function on register click, which will be also empty for now. We will define this later. There we will do a little simulation where we simulate a backend call, but for now it's only defined without any logic. All right, okay, now we can start building our UI. First, I would like to take care of the navigation. We can put this in the util package, because normally the navigation logic is not only in the Auth module, but in the general app or in the core module or something like this. So I will put this in the util package called navigation. This will be a file, composable navigation. And first we will have, well, nav controller. Nav controller is equal to remember nav controller. And then we will have a nav host, which takes our nav controller. And we first need to define a start destination. And for all the different destinations we have, we can create a sealed class screen routes. And this will take a route of type string. And we will have an object, login screen, which inherits from screen routes. We will pass for the route login screen. Then we will have an object, register screen, which also inherits from screen routes. Here we will say register screen, and also let's change this to underscore. And we will have an object, final destination, which will lead the user to when the login or register was successful. Of course, in a real-world application, then you would provide some kind of destination where the user should be directed if the login or register was successful. Final destination like this, and of course needs to inherit from screen routes. And the start destination will be screen routes.loginscreen.route, and then we can open this. To define the different routes, we first need our composables, which we can invoke if a specific route occurs. So we will go to our presentation package, create a new file called login screen, composable login screen, and this will take two Lambda functions. On login, success navigation, which does not take anything and does not return anything. On navigate to register screen, also does not take anything and does not return anything. And a login view model, which is a Hilt view model like this. And we don't need to pass the nav controller here. The login screen does not need to know about the nav controller. We can completely put the logic of navigation inside our navigation composable. Let's see how this works. Here we can define the composable for the screen routes.login screen.route, and we will invoke the login screen then. And for the on login, let's import the login screen first. This one. On login success navigation, we will pass navcontroller.navigate screenroutes.finaldestination.route, and then we will also say pop up to null or 0, because we don't want the user to be able to navigate back after the login was successful. And with this approach, also the login screen does not need to know about the nav controller. We do the navigation really only in this navigation composable with the help of this lambda functions. Then we also have the on navigate to register screen. Here we will say navcontroller.navigate screenroutes.register screen.route, and also we say pop up to null or 0, because otherwise the user can always toggle between login and register screen, and then the backstack gets increased each time the user does such a navigation. Then we can do the same for our register screen. We will say register screen in our presentation package, composable register screen. And I think we can copy from the login screen this 3 parameters or lambda functions. Here we will say on register success navigation, on navigate to login screen, and here we have of course the register view model of type register view model, which is also a Hilt view model. And then we can go back to our navigation, and here we define the composable for the screen routes.register screen.route. Register screen, this one here, and for this two lambda functions, we then say navcontroller.navigate screenroutes.finaldestination.route, and we will say pop up to null, and we can then copy this and paste it down here on navigate to login screen, and here we will change this to login screen as well. And I think we need a parenthesis like this. The last screen we need to define is our final destination screen. Let's go to our presentation package, create a file, final destination. Will be a composable, of course, final destination. This won't take any parameters. Here we will have a simple box with a modifier, which is equal to modifier. Let's import box, remove this wrong import of the modifier, use the compose one, and we will fill the max size, set the content alignment to alignment.center, open the box scope, put in a simple text, import this. The style will be material theme.typography.body1, for example, and the text will be congratulations. Like this. Then we can close this final destination screen. We don't need it anymore, and define the composable here in our navigation for screen routes, final destination.route. And here we simply say final destination like this. And this was it for our navigation. We can also close this screen or this composable, go to our main activity, remove all this default stuff, and simply say navigation like this. All right, we are almost ready to start with our login and register screen and put everything together. Let's set up Dagger Hilt first, and then we can start with the final part of this video. For the setup of Dagger Hilt, we need to go to our root package and create an application class. We will call this Auth application. Make this inherit from application, and we need to annotate this with @Hilt Android app. Then in our main activity, we need to annotate this with @Hilt Android entry point. And in our manifest, we need to define the application, our Auth application. Then we can close the manifest, also close the main activity. And now we need to define the different dependencies for Dagger Hilt, which are right now only the two use cases. We can create a new package from our root package called DI. We will call this package app module, make this an object. This will be a module, so we annotate this with add module, add install in, singleton component, double class. And here we can then provide with these different annotations our dependencies. First, we will say add provides, add singleton, function provide, validate, login, input, use case. This will return a validate, login, input use case, and we can simply say return, validate, login, input use case. Then we can copy this for our register input use case, validate, register input use case again, and down here again. And this was it for the Dagger Hilt setup. Later, when we simulate the backend call, then we will create a repository interface and class, and then we need to provide this here as well. But for now, this is fine, and we can try to start the app and have a look if everything is set up and we don't have any build or compiler errors. For that, select app up here if you have still the test case for the start, and we can select a pixel device and start the application and have a look if everything works. All right, okay, the app starts. This is fine. We can now start to define our login screen and put our different composables together. Let's close this emulator and go to login screen. And here we will start with a box, and this box takes a modifier, and let's do the imports, the compose modifier, the box, and this modifier will fill the max size, and the background will be set to white. Then we can open the box scope. Inside this box we will have another box with a modifier, and this modifier will fill the max width, and the height will be 120 dp. So this will be our for our header background, and we will set the content alignment to alignment.center. Let's open this box scope. Then we will have our header background composable. For the left color, we will have orange. For the right color, we will have white, gray, orange. Then we will have a modifier, and this modifier will simply fill the max size. Below this header background, we will have a text composable. The text will be login. Let's rearrange this a little bit. And for the style, we will have material theme .typography.h4. The color will be set to white. The font weight will be set to font weight.semibold. And then we can just have a look, but starting the application again, we could also provide a preview here. But you can see we have this header background and also the text for the login. One thing I would also like to do is to go to the main activity. And here we will set window.statusbar color to gray.to RGB, and the window.navigation bar color to gray.to RGB as well. Then we can start this again and have a look what this did. And now you can see the navigation and the status bar color is gray. I think this looked a little bit better instead of the default purple or whatever color this is. Then we can close the main activity and continue in our login screen. Now for the main container where the email and the password text field is and also the authentication button, I would like to create a container which takes a lot of Lambda functions which return the necessary information to increase the performance. We can decrease with this principle the recompositions. I already made a video about that to increase performance in Compose, and exactly this principle is applied here. In case you missed this or you don't know about this principle, make sure you check this video above. And now we can define a composable called login container. Normally, you would assume that we pass the parameter email value like this, but this would not make that much sense for this performance improvement because we would need to read the state here. In case we call this login container, we would say something like login ViewModel.loginState.email input, and then we would read the state here. And we don't want to read the state in the whole login screen for performance reasons. We want to read the state in this login container, and we can achieve this by making this a Lambda function which returns a string, and then we can put this inside a Lambda function, read the state there. It's read inside this Lambda function, and here we can, for example, say text email value like this, and then we read the state here in this login container. Well, I won't dive too deep into performance in Jetpack Compose. Make sure you check this video out, which I already made. There I go more into detail. Okay, let's remove this and also remove this and continue with our parameter definition. We will have a password value, which will be also a Lambda function, which returns a string. Then we have if the button enabled, Lambda function, Boolean on email changed, which will be a Lambda function as well, which provides a string and returns nothing. On password changed, provides a string, returns nothing, and don't forget the double colon here. Then we have a function on button click, which does not take and does not return anything. Let's call this on login button click for better readability. The next parameter will be isPassword shown, which does not take anything and returns a Boolean. On trailing passwords icon click, does not take anything and does not return anything. Then the error hint, which returns an optional string. Then is loading, which returns the Boolean. And finally a modifier, which allows us to modify this login container from the outside. In this login container, we will have a column and we will pass the modifier. Let's also import column. The vertical arrangement will be set to arrangement.spaceby 15dp. Then we can open the column scope and start with our text entry module, the composable we defined earlier. And for the modifier, we will pass modifier.fillMaxWidth. The text value, the description will be set to email address. The hint will be set to keyapps at gmail.com. You could, of course, also work with string resources for different languages, but well, I won't do this here. Then for the value, we will say email value and invoke this function to read from the state. The text color will be set to gray. The cursor color will be set to orange. Let's import this gray color. On value changed is equal to on email changed. The trailing icon will be set to null for the email field, and on trailing icon click can be set to null as well. And then we still have a missing parameter. Let's see which one. Yeah, we need to provide the leading icon, which comes from icons.default.email. And then we have our email address text entry module. We can just copy and paste this then for the passwords. Here we will say passwords. For the hint, we will say enter password. We will read from the password value state. Gray, orange is fine. For the onValue change function, we pass on password change. The trailing icon in this case is icons.default.remove red eye, and the on trailing icon click will be also set. And here we invoke on trailing password icon click. And for the leading icon, we say icons.default. What's it? VPN key, I think. Okay. The visual transformation depends on if is password shown. Read the state from here. Then we have the visual transformation none. In the else case, we will have a password visual transformation like this. And the last thing we want to define is the keyboard type. Here we say keyboard type dot password. Oh, I forgot to invoke this function here. Make sure you add this parentheses to actually invoke this function. Below this module, we will have a column with a modifier. This modifier will fill the max width, and the vertical arrangement will be set to arrangement.space by 5dp. This will be for our Auth button, and at the bottom below the Auth button, the hint what's actually going on inside the text fields, if the value is still empty, if we don't have a valid input, and so on. Here we can make use of our defined Auth button composable. Let's import this. The text will be set to login. The background color will be set to orange. The content color will be set to white. Enabled comes from the button enable state, which we read here. Then the modifier will be set to modifier.fillMaxWidth. The height will be set to 45 dp. We will also apply a little shadow of 5 dp, rounded corner shape 25 dp. Then we will pass isLoading, which comes from our isLoading lambda function. On button click is equal to on login button click, like this. And below this Auth button, we will also have a text for the hint, so the arrow hint. And in case this arrow hint is null, we simply pass an empty string. The style will be set to material theme.typography.caption, so that it does not get too big. And yeah, I think this is it for our login container, which can now be used in our login screen. All right, okay, below this box where our header background and the text is into, we have our login container. And now we need to provide all those different state values. Email value is equal to login ViewModel.loginState.email input. Then we have the password value, which is login ViewModel.loginstate.password input. And I think we can copy this kind of a prefix. The button enabled comes from login ViewModel.loginState.isInputValid. After that, we have on email changed. There we can use this syntactical way, pass on email input change with this 2 double colons. Then we have on password changed, login ViewModel dot on password input change, on button click or on login button click, login ViewModel on login click. Then we have is password shown. Here we can again use our kind of a prefix, is password shown. After that, we have on trailing password icon click. Here we invoke on login ViewModel on toggle visual transformation. And can we also use the syntax with the 2 colons here? Yes, I think we can. Okay, cool. And then we have arrow hint. Login ViewModel.loginstate.arrow message input. After that is loading, login ViewModel.loginstate.isLoading, and the last thing we want to pass is a modifier. This modifier has a padding of 200 dp to the top, so that it does not overlap our header background at the top. Then we have fill max width 0.99f, 90% of the width. Shadow will be 5 dp. Rounded corner shape 15 dp. Then we also have a background, white gray, so that it differs a little bit from our main background. Rounded corner shape 15 dp. Then we have padding 10 dp, 15 dp, 10 dp, and 5 dp. And we will align to top center. And we have a little typo here. And yeah, I think this is it for our login container. We can already try this out and launch the application. We should actually see the login container and also the header background. And yeah, you can see this looks pretty cool. The bubbles are still missing, but we didn't define them yet. So let's continue with that. Below our login container, we can then invoke our predefined bubble animation composable. And for the bubble color 1, I think we need to import this first. Bubble color 1 will be white, gray, orange. Bubble color 2 will be orange, and the modifier will be set to modifier.fillMaxWidth. The height will be set to 250 dp, and the alignment will be set to alignment.bottom-center. And then the only thing that's left is at the bottom. Do you already have an account, or do you not have an account? Click on register. So this kind of stuff. So modifier is equal to modifier.padding. We will have a little padding to the bottom of 10 dp. Then we have also alignment.bottom-center. And for the horizontal arrangement, we say arrangement.center. Then we can open the row scope. We will first have a text which says no account yet. Style will be material theme.typography.body2. Below this text, we have an additional text. This will have register as the text value. Then we will also have a modifier, which we will set to modifier.padding, little start padding of 5 dp. I realize at the moment that we could also use this one for the padding. Well, never mind. It will also be clickable, and here we invoke on navigate to register screen. Then we will have a color orange. Font weight will be fontweight.bold, and the style will be material theme.typography.body2. All right, okay, let's try this out and also check if the input actually works. Let me put this in the middle, and the bubbles looking cool. Let's also try to input an email address, keyapps@gmail.com. Empty fields left is the hint. Let's also put in a password. Okay, I think everything works here in terms of state observation and so on. Let's also click on register. There should be a blank screen now, but let's check if this also works. Yeah, this works. Okay, cool. Then we can continue with our register screen. And I think I will just copy and paste everything there, because there's really nothing new in the register screen, and this would be almost identical to the login screen. The only difference there is that we have an additional field in our register container for the password repeated, but the rest is completely the same. So yeah, I will just copy and paste this. Okay, all right, let's go just quickly over it. We have the same setup here, the box inside the box with our header background and the text. This time we have register as the text. Then we have the register container, which takes all the different state values. And we have, for example, an additional state or an additional function here for on password repeated change. Here we have the state for the password repeated value. Of course, also on trailing password repeated icon click. So almost the same, only adjusted for the additional field for the password repeated text field. Then we have again our bubble animation. Here at the bottom we have this row with you have already an account, then you can click on login. And here's our register container. And yeah, I think this is nothing new, and we can also try to start this and have a look how this would work like then. Now we can click on register at the bottom. I hope you can see it. Yeah, should be fine. When I click on register, then you can see we are now in the register screen. Let's also type something in, papps@gmail.com, for example. Then we will enter a password. I will just put in something invalid. Then you can see that we get a hint, password too short. Let's also enter different numbers like this. Then we have passwords do not match. Let's have a look at them. Okay, at the top I have I have only 4 ones, and at the bottom I have 5 ones. Then I enter a new one. Then we have passwords needs to contain at least one uppercase jar. Okay, well, we already tested this with our unit tests, so this should work. And yeah, I think this looks pretty cool. We can go back to login again and toggle register and login. In case you want to save the entered values inside the login screen, then you would need to provide additional logic, but well, I think this is fine so. And the last thing that we want to do now is, if we click on login, then we want to apply some kind of logic. We want to simulate a backend request, show the circular progress indicator, and if the request was successful, then we want to automatically navigate to another screen. Okay, normally network requests or database queries are done in the data layer of our application. So the data layer in our case is completely empty because we don't have any network requests or so. And also in Clean Architecture, you often have repository classes which put together different data sources. In this application here, we will only use a repository class inside the data layer because we don't really have or we don't even make network requests, so we don't need API services or some kind of other interfaces and data classes. We will do this in the repository class, and for that we will go first to the domain layer. Yeah, right, not the data layer, because we need to define the repository interface. So the interface with which our ViewModel interacts in the domain package, because our ViewModel will access only the domain layer, and therefore we need to provide the interface inside the domain layer in this package. And here we will create an interface called Auth repository. And this interface will have 2 suspend functions, suspend functional login, email of type string, password of type string, and this will simply return a bool depending on if the login was successful or not. We anyway just simulate it here. And then it has also a function register, which also takes the email and the password. We don't need the repeated password for the register because well, we already checked that the password matches the repeated password. And yeah, this is it for our auth repository. And then we can go to the data layer and provide a concrete implementation for that. We will call this auth repository implement. This will inherit or realize this auth repository interface. And here we can click on implement members, implement all, and we will provide a really simple solution for that. We will delay this for 1 second, and then we will simply return true. Of course, in a real-world application, you would do some network calls and check on the result, even maybe provide a flow back or some kind of resource wrapper around the return value. But yeah, this is really only about the auth module and not about doing network requests and so. Okay, then we can go to our app module from Dagger Hilt. We can annotate this with add provides, add singleton, because we also need to provide our auth repository. We need to tell Dagger Hilt how to provide this. We will say functional provide auth repository. This will return our auth repository, and the concrete return type will be of type auth repository implement, like this. Then we can collapse this domain, go to our login view model, go up to the constructor, and here we say private val auth repository. And now Dagger Hilt takes care of providing this auth repository, and we defined that it should provide the auth repository implement behind the scenes. So in the data package, this concrete implementation. And in our view model, we only know about the auth repository interface. Here, this one, which is in the domain. And so in terms of clean architecture, the view model only accesses the domain layer, which is absolutely right and how it's supposed to be. If we have then a look at the auth repository implement, we can see this import, which also points to the domain repository of repository. So our interface is in the center in the domain layer, and both the view model and the repository points to it, depends on it. And this is achieved with the dependency inversion principle. And this is a really, really important principle when it comes to clean code, clean architecture, and so on. So yeah, in case you don't know about it, make sure you get informed, because this is really powerful. Now we can go back to our login view model and take care of this on login click function. First of all, we say login state is equal to login state.copy, and we set is loading to true. After that, we can say ViewModel scope.launch, because we need a coroutine scope to invoke this auth repository suspend function. Here we say login state is equal to try, well login result is equal to auth repository.login. For the email, we will pass login state.email input, and for the password, we will pass login state.password input. And after that, we say login state.copy is successfully logged in to our login result. And in case there is an exception, of course, the auth repositories method here can throw an exception, but in a real world application, there can be tons of exceptions that happen when you do a network request, or you can also provide custom exceptions. I handled custom error handling in my last video, which you can check up here. And then you can also provide proper error handling. But here we will say, for the sake of simplicity, just catch a general exception, and then we say login state.copy error message for the login process could not log in. And we will also provide a finally block for process or for state update that always needs to be done. Here we say login state.copy is loading is equal to false. And then this login state gets updated with either this one, or this one, depending on the things that happen when we invoke auth repository.login. And then we can copy this and go to our register view model and paste it in on register click, update this with register state is equal to register state.copy is loading to true. Then the register state is updated with our auth repository, which we need to provide. Private val auth repository like this. And here we call the register function. For the email, we will pass register state.email input and the password input. As I already said, we don't know the repeated password for this request, because the repeated password and the password was actually already checked. Here we can update register state.copy is successfully registered is equal to the, let's rename this register result. And down here we also say error message register process. And finally, we will set register state.copy is loading to false. And here we get a warning, unused result of data class copy. Okay, then the finally block does not set the state here. Here we then need to set register state is equal to register state.copy. We also need to do this for the view model. Here we say login state is equal to login state.copy. Okay, this is it for the view model. And now we also need to take care of the navigation in case this login state is successfully logged in, set to true. For the automatic navigation, we need an additional composable component. Let's create this and call it nav destination helper. You will see why this also increases the performance. It's the same principle like we had before, using lambda functions to read the state, not on the root composable. Here we call this nav destination helper, and we will pass should navigate. This will take nothing and return a boolean, and we will also pass the destination, which does not take anything and does not return anything. And then we can use a launched effect, and for the key we pass should navigate, so we read this state inside the launched effect here in the scope of this nav destination helper. Then we can open the scope, and if should navigate is true, then we will call our destination. Back in our login screen, we can then make use of this composable. Right above at the top, we will say nav destination helper, and for the should navigate, let's first import this. For the should navigate, we pass login ViewModel dot login state dot is successfully logged in. Then we again only read the state in the scope of this composable and not on the login screen. This will avoid unnecessary recompositions. Then we have the destination, and the destination will be on login success navigation, like this. Then we can copy this and go to our register screen to the top and paste it here. And here we will have the register view model, register state is successfully registered. And for the destination, we will pass on register success navigation. Okay, fine. Now we can try this out, launching our application. Here we enter an email address, keyapps@gmail.com. We enter some random passwords and click on login. Then you can see the circular progress indicator and also the automatic navigation to the next screen. We can also check this for the registers functionality. Let's click on register. Here we again has an email address. Then we will enter a password. Repeat this password. Okay, I see this button here still says login. We need to change this button text to register, of course. Let's click on it. Now we can see, okay, this works fine as well. Let's quickly change this in our register screen. Close the emulator, and this is here for the Auth button. No, it's where's the Auth button? In the register container down below. Here, we need to change this to register. All right, okay, this was it for this Auth module in terms of clean architecture, MVVM, and I hope you get a slight overview how this could potentially look like. Feel free to use this code and modify it a little bit to your own needs. Of course, also with a corresponding backend. You could, for example, provide additional functionality like forgot password or stay logged in or something like this. But yeah, I think with the unit tests and also the clean architecture principles, the clean code structure, this can be a really good example for real-world production app application. And yeah, thanks for watching if you made it this far, and we will see us in the next video.